Hi, my name is Jennifer Hahn, and I am in Section I of 15112. This is my 15112 term project. For this term project, I decided to program the game Pac-Man with artificial intelligence. Here is the home screen, the first thing the user sees when the program begins running. You press the S key in order to begin the game. Now we have the board screen, where the player controls Pac-Man through the board by using the arrow keys to move up, down, left, and right. In order to encourage and keep the user's interest, the beginning few levels are fairly manageable to win. As you can see, the ghosts are moving fairly slowly around the board. When the Pac-Man eats all the food or little yellow dots on the board, the level increases and the level up screen appears. The biggest feature of my program for Pac-Man is the artificial intelligence of the 4 ghosts. My ghosts use the chase and scatter method. Each ghost is initially assigned to be in the chase mode. The ghosts have a target location where they are trying to get to at all times. In the chase mode, the target location of the ghost is the location of the Pac-Man on the board. Scatter mode works a bit differently. Since there are 4 ghosts, I programmed each of the ghosts to have their own home base. For example, the pink ghost's home base is the top left corner of the board. The red ghost's home base is the top right corner. The orange ghost's home base is the bottom left, and the cyan ghost's home base is the bottom right corner of the board. When the ghosts are in scatter mode, their target location is their respective home bases, and their target locations are those respective grid cells. This chase and scatter mode method makes it so that the ghosts are not chasing the Pac-Man at all times. However, they have artificial intelligence because they are able to sense or track where the Pac-Man is and adjust their movement according to the changes in the Pac-Man's behavior. For every 2 steps the ghosts take in the direction of Pac-Man, it takes 1 step in the scatter mode. The ghosts constantly toggle between the chase and scatter methods. Now, we will look at the pink ghost as an example of this artificial intelligence. As you can see on the screen, this is the pink ghost's straightest path to the Pac-Man. However, the pink ghost first takes 2 steps in this direction on the path, and then takes 1 step away. For the pink ghost, their home base is in the top left corner of the board. As the levels increase, the ghosts also begin to travel and move around the board faster, and I implemented this by just decreasing the delay in the timer fired so that each move is made with less time in between. Thus, as each level increases, the ghosts get smarter or seem to develop more effective ways to chase and find Pac-Man as they move around the board. This artificial intelligence makes Pac-Man compelling for the user. Now I will reload the program and show how as the levels increase, the ghosts get faster as they move around the board. Notice how in this first level, the ghosts are moving fairly slowly. Onto level 2, the ghosts are moving a little bit faster. As each level increases, the ghost's speed increases, and the enemies or the ghosts get smarter and more agile. And at level 7, the ghosts are moving very quickly. If Pac-Man collides with one of the ghosts, the Game Over screen appears, and your final score is displayed. Here, Pac-Man and the ghosts touch each other, and thus the game is over. This is my 15-112 term project, the classic game Pac-Man, with artificial